In this video here, we're going to learn on how to sketch cubic functions by using the idea of the simple steps in graphing. So when the time I want to use the simple step in graphing, the techniques here, I will focus on the cubic functions that can be written in this form here, where we're able to have the x terms being written to the power of 3, and then the rest of the parts is just constant, like this form here, where a is not equals to 0. Of course, cubic function also we can have some other form, like we have cubic functions which can be completely factorized, whether it's completely factorized into, for example, maybe I can have 3 linear factors like this. Or maybe I can just have it factorized in the form of 2 linear factors where one of it happens to be repeating, for example like this. Okay. Anyway, in the intro here we will focus on this type of form. The other two types we will see the techniques of sketching in the example 2 and 3 later. Maybe it will be slightly different from this technique here, the simple step in graphing. Okay, go on. Next. So once again, what is the idea of the simple step in graphing here is that it's just actually we refer to the type, the shape, special point or line, intercept, and also lastly go for graph. So without further ado, let us see what the idea of the type of functions here. So we want the cubic to be written in this form here, the cubic function written in this form here, where your a is not equals to 0. For example, in this first example here, you can see that we have x minus 1 to the power of 3 plus 2, where you can see if compared with the function on top, the a, h, and k are corresponding to positive 1. The a here is positive 1. The h here is referred to negative 1. K is 2. The next one, fx equals to negative 3 bracket x plus 1 power of 3 plus 10. So a, h, k. The next one, you see that it doesn't really looks like the form that we have in general here originally, but we notice that we can convert it by doing factorizations, where we try to factorize negative 2 out. By the time you factorize negative 2 out, you have negative 2 power 3 and give us the result of negative 8. And once again, this form here example the form that we have on top here to the a, h, and k accordingly. Then last one, it can be as simple as x cubed minus 1, where we can see that this case here as if like I have x plus 0 to the power of 3, where your h is corresponding to 0. So these are the type that we have. So after identify that is this type, or I can convert into this form here, then next we want to consider the shape of the graph. So how will be the shape of the graph if let's say I can have x plus h power 3 form? So it will happen to have the form like this, where in this graph here I have an important point at here. Later we will discuss in the third step there. Anyway, when the time I happens to have the coefficient for x cubed to be positive, so this is the shape of the functions, the shape of the graph. And let's see some of the examples that have this shape here. For example, let's see when the time I have positive coefficient on x cubed, as simple as the basic case, y equals to x power 3, y equals to x plus 1 power of 3. But we can see when the time you expand, the coefficient of x cubed is positive. So do the rest of them, as you can see. Then next, continue. When the time I have the case that I have negative coefficients for x power of 3, what will happen to the graph that we have is that you find out that the shape of the graph will just as if like we have it flipped horizontally. And the shape that I have is like what is shown in this diagram here, for the case that coefficient for x cubed is to be negative. And some of the examples, like what I happen to show here, y equals to negative x cubed, y equals to bracket negative x plus 1 power of 3. When the time I do factorization or expansion, I can see that I have the coefficients to be negative, so do the rest of them, as you can see. And once again, the shape of the graph that I have here is only applied for the case that I can have the form a bracket x plus h power of 3 plus k, where I can achieve the cube terms here, the bracket cube terms here. If let's say I have some other form like just now I happen to mention, if I have the case that completely factorized, then the shape of the graph may not look like this, and we will see this, we will discuss this in the example 2 and 3 later. But in the general discussions here, we just go for this shape of graph here. Go on. Next, in cubic, what is the special point we have here is correspond to the reflection point. Inflection point. So inflection point, it will refer to this point here in the graph. Of course, it happens to reflect the other way, it will be still refer to the same positions here. Okay. So how we identify the inflection point? So basically what you can see is that to identify the inflection point, we are just referring to the bracket parts here. For the x coordinates, where we in time we have x plus h equals to 0 for the x coordinate, then the k here for the y coordinates. And these are some of the examples for the corresponding functions to have their inflection point. Next, after I happens to identify the inflection point, the important point, by right I can do a rough sketch to identify whether the y and x intercept whether exists or not. And if it happen to exist, then we will do calculation to obtain the answer. For y-intercept, it will be just as easy as substitute x equal to 0 inside to get the answer. For x-intercept, maybe we will just solve using calculator rather than calculate manually. And lastly, we can go for graph sketching. And in your graph sketching, make sure you have labeled the xy axis, the origin, label the name of the graph, the important point, inflection point in this case here, the y and x-intercept if it happen to exist. So this is the intro on how to sketch cubic functions, where it will refer to the case that we can express in the form of a bracket x plus h power 3 plus k. Next we will follow by the example.